Okay, let's start today part. So last 2 weeks we have done the indefinite integrals, no? Indefinite integrals. Then today I'm going to discuss about mainly definite integrals and further integration part. Definite integration and further integration part. Okay. Now see first what is indefinite integrals and definite integrals again. Now you identify indefinite integrals. Indefinite integrals. Indefinite integrals. Here you consider function fx. Function fx integration. We write here capital Fx plus c. C we call arbitrary constant. C we call arbitrary constant. We can't get exact value, therefore we say that is indefinite. Indefinite. Then definite integral specialty. Here now it is like this. Definite integrals. So now integral like this a to b fx kind of thing dx. Then usually fx integral we denote by capital Fx. No? Then same results we get. We get same result capital Fx. Here this is called definite integral. But we don't use constant. We don't use arbitrary constant. You just forget it. Then we don't have arbitrary constant. But here we have lower boundary. With square bracket you write here a, and here upper boundary you write here b. Lower boundary and upper boundary. Here lower boundary. Here upper boundary. Then further for this case we write capital F. Upper boundary we substitute the function first. Upper boundary. Then substitute lower boundary. Then subtract. Here final answer. Then that is definite integral. So definite integral means this definite integral represent an area. Here x-axis, y-axis, you consider a function like this, say y equal fx. Then here, say a, here b. Then that definite integral represent this area. Here this area represented by definite integral, a to b fx dx. Fx dx. Then usually by definite integrals we can find areas, volumes and so on. Okay, that is about definite integrals. Okay, first write this one. First write this one. First write this relation. We have two different types of integrals. One is indefinite integrals, the other one is definite integrals. So here definite integral, it has limit, lower limit and upper limit, or lower boundary and upper boundary. And here same results we obtain integral capital F, simple fx dx, the result capital Fx. Na? Here we don't use arbitrary constant c, but here we need to use arbitrary constant. Then here upper boundary, upper limit you write here, lower limit you write here. Finally, substitute upper limit, then lower limit, subtract it. That's how we do it. Then as an example, integral x square dx. It is very simple. X cube over 3 plus c. Then for this case, example, here 1 to 2 x square dx. Here x square integral mean x cube over 3, don't use arbitrary constant. Lower limit 1, upper limit 2. Then after you substitute upper boundary, 2 cube over 3, then substitute lower boundary, 1 cube over 3. Subtract. Then 7 divided by 3. 7 divided by 3. Then we have a definite value for this. But here we don't have definite value. It is indefinite. It contains variables. Then here definite integral. Okay. Write all. Write all. Okay. Now you write there. A definite integral. A definite integral. A definite integral has a lower limit and upper limit. The corresponding result has definite value. The corresponding result is a definite value. Is a definite value. Corresponding result is a definite value. Definite value. Usually, by the definite integral, that represent area bounded by area bounded by the curve and the x-axis. Area bounded by the curve and the x-axis. Okay, now you do with me these examples. Do with me. Sin x dx 0 to pi over 2. Then sine integral minus cos x, 0 to pi over 2. Then take minus outside. Then substitute upper limit, cos pi over 2 minus cos 0. Cos 90 0, cos 0 1, answer 1. Answer 1. Then here 2x divided by x square plus 1 dx, 1 to 2. Do with me. Now here we have denominator derivative in numerator. We know that case. We can put ln x square plus 1 mod 1 to 2. Then substitute upper limit, substitute lower limit, ln 5 minus ln 2. ln difference mean log division, ln mean logarithms. Then general integration type you can apply. Then finally you put limit relation. That's it. Third one, x over x minus 1 dx. Here 1 plus 1 over x minus 1, division algorithm. X minus 1 cancel. Then 1 integral x, here 0 to 1, 0 to half. Then denominator derivative in numerator, ln x minus 1 modulus, 0 to half. Then substitutes half first, 1 over 2 plus ln half minus 1. Then substitute 0, subtract, minus 1 modulus. Half ln half, half plus ln half. ln 1, ln 1 means 0, log 1 0. Then finally 1 over 2, ln 1 over 2. Likewise, we can do definite integration. Then usual technique you follow. Then finally apply definite integral relation. Definite integral relation. Okay. Now let's see a few applications with definite integers. Okay, write down topic. Find in areas. Find in areas bounded by the curve and the x-axis. Bounded by the curve and the x-axis. Find in areas. Okay. Now see that this one. See this one. So by definite integration, we can find area, we can find volume, we can find mass, we can find center of gravity, we can find moment of inertia. Likewise, we can find different variables. Okay. Then now you consider a function y equal fx. Here x-axis, y-axis. Then here y equal fx function. So you consider here point A, here B, value A and B. Then here corresponding values. Say before that here AB. Then take here x distance and give small increment here. Give small increment. That increment say dx. Then corresponding variable value y. Here let this one L1. Here let this value L2. Then AB are fixed values, no? AB are fixed values. Here it is a function. Now, when you consider this tiny part, it is a trapezium. No? It's like a trapezium. But if you zoom, then we can see a part like this. So if we break it again into another few small parts, then tiny part, now it is like a trapezium now. So you can zoom and you can again split. So anyway, at the small tiny part, we can consider in that way like a rectangle. That means as delta x goes to 0, here this trapezium kind of thing, here this type of thing that tends toward a rectangle. Okay. Then here the small part area, you say dA. Small part area, you say dA. dA equal here thickness dx, here height y. Y times dx equal dA, small tiny part area. Then y mean now function fx. Dx dA. Then you put integral a to b dA. By this integral a to b dA, we're gonna add those type of small parts. We're gonna add them. Likewise, you split here. Then by integration, we take addition, continuous addition. Then here, integral a to b fx dx. Then for this part, we say area, and here a to b fx dx. Then this part we call area bounded by the curve. Therefore, when we integrate a function within a given limit, that represent the bounded area. Okay, that is fundamental definition of area. Okay. Now further, using this definite integration, we can find volume. Now you think this function, I'm going to rotate about the x-axis. Then that make a solid body. Consider this plane figure. Then you rotate it. Then it create a solid body. Now it is like this. Here x-axis, y-axis. You consider here y equal fx function. So I'm going to rotate it, this plane, I'm going to rotate. Now within this region, AB, so when it rotates, it makes a solid body. Solid body. So I'll do this, say, take x distance, cut this part, small part, with thickness you take dx. So if you separate that one, now the diagram like this, here radius y, then here thickness dx. It's like this, dx. Then volume of this part, we say dv, let's say dv, here radius y, thickness dx. Then write here pi y square dx, radius y. Here pi y square multiply by dx. You forget that slant part. Huh? If that is very small part, therefore you can forget this tiny part, sorry, slant thing. You can consider that one like a cylinder. Okay, now pi y square dx. Pi y mean fx dv. Now you add a to b, those type of small part. Using integration, we take addition. Then pi fx square dx, a to b integral. Here we say volume. Then a to b, then pi integral a to b fx squared dx. Here this represents volume. So when you rotate this function around this x-axis, then pi fx square dx represents volume. Then if you integrate function within AB region, that represents bounded area, curve and the x-axis. Likewise, you can find this curve length of the curve by integration. See this one? Now consider this. Here x-axis, y-axis. Consider this part. Here AB region. You take this part. Here x distance. Here say this tiny part delta x. Then corresponding increment here delta y. Say delta y. And consider this one delta L. Here slant part delta L. Consider this triangle. Okay. Now delta L equal delta x square, delta y square plus delta x square root, no? By the Pythagorean theorem. Now you take delta y outside, delta x outside. Then here delta y divided by delta x squared plus 1 root, take delta x outside like this. Take delta x square outside, then delta x square within square root, then delta x goes to outside. That's it. Okay. Now further, you take here delta x. You put integral 1 plus delta y over delta x square delta x. We say delta L integral. Then usually here delta x means length, no? So as delta x goes to 0, delta y divided by delta x, we say dy by dx, no? Dy by dx. Limit delta x goes to 0. Dy by dx. Therefore, with integral that contain limit, So as delta x tends to 0, it so close to each other. No? Therefore, for instead of this part delta y over delta x, you say dy. Dy divided by dx. And for this case, you say dx. Then here this part, you say dl now. Then you do that integration a to b region. A to b region. Then that represent length of this curve. Length of this curve, say L. Then a to b 1 plus here dy over dx mean f dash x square root dx. Here this represent length of the curve. Length of the curve. Then integral a to b fx dx represent area. Integral pi fx square dx represent volume. Then integral a to b 1 plus f dash x square root dx represent length of the curve. Length of the curve. But don't worry about length of the curve part. But anyway, this area and volume thing definitely with your A-level examination. Okay, that is the definition of area, find in area, find in volume, and find in length part. Okay, first you write this relation, then you go to here, then you go to here, then finally get last one. Okay, write on. Okay. Now see this relation. See this relation. Consider y equal x square function. Y equal x square function. Here x axis, y axis. So here full function in first and second quadrants. Na? For some function can be in first quadrant, some can be in second quadrant, third quadrant, fourth quadrant, likewise. Sometimes 2 or more quadrants can be there. But here x square in first and second quadrants. So now you consider here 1 and 2. Then I'm going to find this bounded area. Now let's see what will happen by this example. Now you take area 1 to 2 function x square dx, then x cube over 3, 1 to 2, then substitute 2, 2 cube over 3, substitute 1, 1 cube over 3. 8 minus 1, 7 over 3 is square units. 7 over 3 square units. Then directly you can get area. So if the function in first quadrant, then definite integral represent directly area. Now you take this part. Here again 1, minus 1 and minus 2. I'm going to find this area. So let's do this. Say you do integration. I'll do it here. Then minus 2 to minus 1 x square dx. Minus 2 to minus 1 x square dx. Then x cube over 3 minus 2 to minus 1. First substitute minus 1. Minus 1 cube over 3 minus 2 cube over 3. Then here plus 8 minus 1. 7 over 3 square units. So if the function is second quadrant, that also represents completely area. Now you consider y equal minus x square function. Take this one. So when we sketch this, here x axis, y axis, the curve like this. So the function in third and fourth quadrants. Function in third and fourth quadrants. Now you try to find this area. Here minus 2, minus 1. Let's do this say. Say a equal minus 2 to minus 1. Function minus x square dx. So now let's see what will happen. Take minus outside, x square integral x cube over 3, limit minus 2 to minus 1. Then substitute upper boundary minus 1 cube over 3 minus 2 cube over 3. So we get minus 7 over 3 now. Here we have doubt here. Usually area always positive, but we get negative value here. Therefore definite integral represent not exactly area. But if you need to find area, we can apply definite integral. So if we need to find area, we can apply definite integral. If the function in fourth quadrant, third quadrant, then you need to put modulus. That's it. That's all. Then you can remove this minus sign. 7 over 3 square units. Then you identify if the function in first and second quadrant, then no worries, we can directly integrate to find area. So if the function in third quadrant, then we can integrate, definite integration you can do, and finally you put modulus sign. That's it. Then let's see the function in fourth quadrant. Let's see again what will happen for this part. Then area 1 to 2 minus x square dx, take minus outside, then x cube over 3, 1 to 2, 2 cube over 3 minus 1 cube over 3. Here also we get minus 7 over 3. Then for that case also same, no? You put modulus sign. So if you need to find exact area, then you need to think about where the function lies. Okay, that means you need graph. No? Graph එක නැතුව මේ වැඩේ කරන්න බෑ. Then need to consider about graph. Okay, then put star mark and write down. When finding area bounded by the curve and the x-axis, when finding area bounded by the curve and the x-axis, the position of the function must be analyzed first. For first and second quadrants, for first and second quadrants, direct definite integral represent the area. Direct definite integral represent the area. But for third and fourth quadrants, need to put modulus sign. To the definite integral to find the area. Okay. Now you get this example. Example. Put it. Okay. Now, next topic, theorems on definite integers. Theorems on definite integers. Theorems on definite integers. Okay. Now, here also these are very important again. So, definitely in your level examination, definite integral will be there. Finding area volume will be there, and theorems must be need to be applicable. Need to apply there. Okay. Now consider a to b fx dx. Here theorem number 1. So instead of x, you can put any other variable. A to b ft dt. No worries. Same integral. As an example, sin x we can integrate. Sin t we can integrate. Same results we can obtain. Sin t dt integral equals sin x dx for definite integrals. Then variable change won't affect. Then here first theorem, ft dt. Then second theorem, a to b fx dx. So when you interchange a and b, then b to a fx dx, then sign will be changed. When you interchange limits, sign will be changed. Third, a to b fx dx. Now you consider there's c value in between a and b. Then you consider here continuous function. A to, you integrate a to b, then you cut it into a to c, fx, and c to b, fx. Likewise, dx. A to b fx dx, integration you can do a to c, then c to b. Can split it. Then fourth and fifth one very important. 0 to a fx dx. Here 0 to a fa minus x dx. Fifth one, a to b fx dx. We say a to b fa plus b minus x dx. These are very important theorems. Okay. 0 to a fx dx, 0 to a minus x dx. A to b fx dx equals a to b a plus b minus x dx. Definite integers. These are theorems on definite integers. So later we will see how to apply them. Okay. Now for now we just write theorems. Okay. Write it now. Okay. Now see theorem proofs. See theorem proofs. First one. Here let integral fx equal capital Fx plus c. Let integral fx equal capital Fx plus c. Then proof number 1, integral a to b fx dx. So you take substitution, let x equal t, then dx equal dt. Then as x goes to a, y goes to, t goes to a. X goes to b, y goes to, t goes to b. X equal t, no? Then a to b, ft dt. Ft dt. Here left hand side equal right hand side. Here first proof. Then second proof, a to b fx dx. A to b fx dx. Left hand side. You take integral capital Fx. A to b, no? Here definite integral. Then here fb minus fa. Here integral fx, I took capital Fx. Then a to b fx dx, you write capital Fx a to b. Then fb minus fa. Then further you write, take minus outside. Then fa minus fb, no? So by this you can go this side. Then by this you can go reverse. Then f a minus fb you write, it's square bracket, capital Fx, here upper limit a, lower limit b now. Then for this one, write b to a, fx dx. Then a to b fx dx, we write capital Fx, b upper limit, a lower limit. So if we have fx ab like this, then b to a fx dx. Now that equal to right hand side. Right hand side. Now first two theorem done. Then third one, take right hand side, a to b, a to c fx dx plus c to b fx dx. Then here capital Fx, a b, a c plus capital Fx, here cb. Then fc minus fa plus fb minus fc. Then cancel fc. Then fb minus fa. Fb minus fa. Now you reverse this. Then fx square bracket upper boundary b, lower boundary a. Then reverse a to b fx dx. Then a to b fx dx equal a to c fx dx plus c to b fx dx. That theorem used to integrate piecewise functions, modulus functions. ඒ වගේ වල තමයි මේක අපි apply කරගන්නේ. Okay. Write them. Okay, now next two theorem proof. These two theorems are very important theorems. 0 to fx dx, 0 to a minus x dx, and 0 to a to b fx dx equal a to b a plus b minus x dx. Very important theorem. Definitely these are with your exam. Okay, now take right hand side 0 to a fa minus x dx. Now let a minus x equal t. Then a derivative 0 minus x derivative dx, t derivative dt. Therefore, dx equal minus dt. Therefore, as x goes to 0, as x goes 0, t value a. As x goes to a, t value 0. Then 0 corresponding t value a corresponding t value 0, then ft dt. ft dt. Okay, by theorem number 1, here d minus dt. By theorem number 2, here it is a to b fx dx, b to a minus b to a x dx. No? Therefore, you can remove this minus sign by interchanging 0 and a. Then 0 to a ft dt. Here theorem number 1. Theorem number 2. No? Then ft dt you can write fx dx. 0 to a fx dx. Here theorem number 1. Now that equal left hand side. By theorem number 1 you write this and t replaced by x. By theorem number 2 remove minus and interchange limits. Now take this case right hand side a to b f a plus b minus x dx. You take this part as t, a plus b minus x equal t, differentiate a0, b0 derivatives, minus x derivative minus dx, t derivative dt. Then dx equal minus dt. As x goes to a, t goes to, substitute a here, a minus a0, t goes to b. As x goes to b, t goes to a. Then a you put b, b you put a. Here ft, dx you write minus dt. Then by theorem number 2, interchange a to b, remove sign ft dt. Here by 1, theorem number 1. Now instead of t you put here theorem number 2, instead of t put x. A to b fx dx equal left hand side. That's how we prove fourth and fifth one. Okay, do them. ඔය දෙක සමහරලාට ඔයාලට ප්‍රූව් කරන්න දෙන්න පුළුවන්. මේ දෙක. Okay. Now see these relations. Now see these relations. Area finding again. Now you consider the graph in first quadrant and second quadrants. First quadrant and second quadrant. You take here first quadrant. So if you need to find this area, you just integrate a to b fx dx. A to b fx dx. So now graph in second quadrant, AB, to find this area, you do same. A to b fx dx, that represent area, shaded area. Okay. Shaded area. Now you consider third quadrant. Here AB, to find this area, you integrate A to b fx, but need to put modulus, na? Fx dx, put modulus outside. Here that represent area. Then function in fourth quadrant, similar thing. Here to find this area, you say A to b fx dx. Put modulus A. That's how we find area. Okay. Now you consider function in both first and third quadrants, or first and fourth quadrants. Consider this way. Here x-axis, y-axis, a function like this. Here if you need to find area within this region, take here intercept C, then here function fx, you need to integrate a to c first, a to c fx, but we get negative value, no? Negative value. Then for that part put modulus. Then c to b fx dx, c to b positive region, then positive. No need to put modulus here. Okay. Then consider here x-axis, y-axis, a function like this. Here a, b, c. Here b. Then here the shaded area represented by a to c fx dx, that is positive. Then c to b fx dx. So that part negative. Put modulus for that. That is area. Okay. Those are area relations again. Hari. About part එක දාගන්න. මෙතන මේ මොඩියුලස් එක දාන්නේ න ආන්සර් එකට විතරයි. يعني ෆන්ක්ෂන් එකට මොඩියුලස් දාලා ඉන්ටිග්‍රේට් කරන එක නෙවෙයි මේ කරන්නේ. මොඩියුලස් එක දාන එන ආන්සර් එකට. පාඩම මේක මේ මයිනස් කියලා ඉවරනත් කමන්නේ. a to b fx. මේ මයිනස් එන එක ආයි මයිනස් එකෙන් ප්ලස් කරගන්නවා. මේකත් ඕකේ. මෙතනත් පාඩම මෙහෙම ගත්තත් කමන්නේ. a to c fx dx c to b fx dx. මේකත් අවුලක් නැහැ. ඒ මයිනස් එකෙන් ආයි ප්ලස් කරනවා. Okay. Now see this one. Write down next topic. Area bounded by two curves. Area bounded by two curves. Area bounded by two curves. y2 equal gx, y1 equal fx. Then here this region, to get that region, you do this say, integrate a to b fx first, then integrate a to b gx, a to b gx, then subtract it. That is the shaded area. Then you write a to b fx minus gx dx. That's how we get bounded region. Bounded region. So the function here x-axis, y-axis like this. Here y equal fx. Here y equal gx. Then here this area AB. A to be fx dx. Represent this area. Then a to be gx dx. Then put minus sign. That also represents same area. Gx value minus, take a plus karana by multiplying minus 1. Then finally, a to be fx dx. Fx minus gx dx. This represent bounded area. Always function difference represent area bounded by 2 conditions. එතකොට මේක අපිට ෆන්ක්ෂන් එක උඩ පල්ලේ කවුද කියන එක තියෙන එක අඳුර ගන්න බෑ නම් ඔයාලා මෙහෙම ගන්න. X axis, y axis. Here a to b fx minus dx dx. මෙහෙම නිකන් just modulus එක දාන්න. අපි කොහෙද තියෙන්නේ කියලා දාන්න. තමයි ෆන්ක්ෂන් එක කවුද කියලා දාන්න. ඒතර ආ ඩිෆරන්ස් එක ගන්න සෙට්. හැබැයි මෙතන අර කොන්ෆරන්ස් මාර්ක් කරලා තායි කතාවක් වෙනස් වෙනවා. හරිද? එහෙනම් ඒ වගේ තැනකට හොඳම දේ තමයි ඔයාලා පුළුවන් තරම් ෆන්ක්ෂන් දෙක ඔය විදිහට තියෙන්නේ කියලා ස්කෙච් කරගන්න. ඊට පස්සේ තමයි අපිට ආන්සර් එක යන්න පුළුවන්. හරි. ඔය පොයින්ට් එකක් දාගන්න.